Okay, good. Then we're just going to do some basic.
Do I have to write down the code?
You okay?
I got other paper and then I grabbed a notebook and I got it.
Oh, great. Okay, so anyways, we're going to be looking at some just really basic stuff today. So first what you guys have to be able to do, and this is something that you will be asked to do on the test, is basically identify whether a pair of angles are, and here's the 5 special pairs, corresponding alternate interior, alternate exterior, and same side interior and same side exterior. Those are going to be the types of angle pair relationships that we have formed when we have two parallel lines and another line called the transversal that cuts through both of those. And so we're going to be looking at today, we're going to take the first couple of minutes here, actually talk about what each one of those are, and then we're going to take a break from notes. We have an Inspire activity where you guys are going to look up the relationships with each one of those special pairs. And then we'll come back to notes and finish it up from there. So when we talk about parallel lines, what does it mean to be parallel? Sam?
They run side by side, never intersect.
What do you mean side by side?
Like they're both going diagonal, horizontal, or vertical, and they are straight, and they're meaning they're parallel, so they'll never intersect.
Oh, okay, so that's sure what we get, right?
Yeah.
Parallel lines never intersect? You're wrong.
Well, I
But
realize you said that
we'll
earlier,
take that
but-
definition. I'm going to prove to you later why you're wrong. But parallel lines do intersect. That I will prove to you.
So why do they always tell us that they don't intersect?
Well, if you live in a two-dimensional world, unfortunately, which we do not, in a two-dimensional world, and that's what we call planar geometry, because therefore you're on a flat plane, they would therefore run infinitely and never intersect. The fact that we live on a sphere means that our parallel lines can intersect, and they do. We'll show you that later. So basically parallel lines are two lines that do not intersect. And the other key to that is they have to be coplanar. All right, so there are a pair of coplanar lines that do not intersect. So a pair of coplanar lines that do not intersect. So what are my parallel lines in this diagram? AB and CD. All right, so therefore AB is parallel to CD. Now there's this new term you guys probably have heard of before. I'm hoping maybe you've heard it. It's called the transversal.
Kinda. Don't remember what it means, but I heard.
Okay. All transversals is something that intersects multiple things. So in this case, the transversal, and we're going to use that term a lot in this unit, the transversal is a line that intersects the two parallel lines. Okay, so the transversal is the line that intersects the two parallel lines. Alright, so then what is my transversal in this problem, or this diagram? FE would be my transversal. So notice it's intersecting. Alright, and then we're going to talk about skew. I know we somewhat talked about this before. A lot of you guys are like, Mr. Sean, I don't really know a good way to describe skew. So, here we go. Let me grab 2 meter sticks. Where are my meter sticks? They're over here. Okay, if I grab 2 meter sticks, this is actually a really easy thing to model. Remember, in order to be parallel, you have to be on the same plane, correct?
Correct.
Right, have to be coplanar lines. So, just go with it. So parallel lines, right? For the most part. Okay? What about now?
Now they're
Now they're just intersecting lines. Hey, what angles are these?
Right.
Vertical angles. And what do we know about vertical angles?
They equal
They
each
are
other.
equal.
Okay, good. That's just something I just wanted to see if you guys remember that from last year. Remember vertical angle? You got the x, you got vertical angle. Okay? What is this? Perpendicular. Okay, and what do we have when we have perpendicular lines?
Right.
4 right angles. Okay, so by definition, perpendicular lines, it forms 2 right angles. Now, parallel, intersecting, and then perpendicular. And that's if the 2 lines are coplanar, right? And as Sam said, parallel lines are lines that never intersect. I said you're wrong.
Right.
Because, what do I have here?
But they're not parallel.
But they're not intersecting.
But they wouldn't be considered parallel because there's not 2 lines that.
They are definitely not parallel. I agree with you on that.
So how does that prove that parallel lines intersect?
It doesn't. This just violates your definition of parallel lines. These are not parallel, yet they do not intersect.
They're 2 different lines on 2 different planes.
There we go. They're not coplanar anymore. This is what we call skew. Probably the best real world example of skew would be an expressway and the overpass. Alright, and that's what skew means. You're 2 different planes. So when we look at our diagram up here, and I look at EC, a line that would be skew to EC would be AB, DB, or HG. What about BG? BG and CE, are those skew?
Yeah, because they're on 2 different planes.
Unless the plane went at a diagonal, at which point they're now parallel. They're actually coplanar lines. It's kind of a hard thing to see, but basically if you can envision a plane coming down at a diagonal, they actually are coplanar lines.
Okay, so then would EF and CD be coplanar?
These would be coplanar, they're on the same plane. EF and AB would also be coplanar. Again, think about the long ramp coming down.
Then what do you
Wait,
Skew,
EF and
well,
CD
again,
are
think about EF
Okay.
and BG would be skew. Okay, that would be a type example of skew.
Well, since that's in 2D format, the graph and below the lines, couldn't that also be a skew if you made it 3-dimensional?
Only if FE was non-coplanar with AB and CD. It would therefore be skew. Alright, so that's parallel transversal. So now, let's actually go into each one of our special types of angles. So the first one is correspondent. What does it mean to say that something corresponds together? A little louder, Mason.
They go together?
They go together, right? They kind of match. So we're talking about matching with this setup. Again, let's kind of take a moment here. These are my parallel lines, and then this is my transversal. So we're talking about matching. They have to be in the same general location. So if I look at angle 1, alright, so if I'm looking right here at angle 1, what angle corresponds to angle 1?
4. Wait,
And we're looking right here at angle 1. What would correspond? What kind of matches number 1?
5.
5. Very good. Alright, so your corresponding angles, they're going to be the same general location. So an example of that would be angle 1 matched with angle 5. And the reason is, think about it as an individual line. You have your top parallel, you have the transversal, and angle 1 sits on the upper left of that intersection. So when I come down to my bottom parallel, what angle sits in the upper left of that intersection? 5. So angle 1 corresponds to angle 5. So they're corresponding angles. And we actually have a total of 4 pairs of corresponding angles. So angle 1 corresponds to angle 5. What does angle 3 correspond to?
7.
7. Angle 2 corresponds to angle
6.
6. And then the last one, angle 4, corresponds to angle 8. So those are corresponding angles. This would be a good one if you guys had colored pencils, and I would just kind of do a quick diagram of maybe just one pair of corresponding angles. You kind of shade it in or something like that. Okay. Now, alternate interior. What does it mean to be alternates? If you're alternating, what are you doing? You're going back and forth, you're changing, right? And the word interior implies what?
Inside.
Inside, okay. So inside means we're between the two lines. So therefore 3, 4, 5, and 6 are interior angles. They're inside the two lines. Alternate means we're changing sides.
Ah, so 3 and 6 and 4.
3 and 6, so angle 3, and angle 6, and what's the other pair? 4 and 5. And guys, here's the best thing I can tell you to do. It's really easy to identify alternate interior because all you have to do is look for the Z. And as long as you have a Z, you've got alternate interior angles sitting in the corner of the Z. It's really easy to identify those. So that's alternate interior. Alternate exterior is almost the same concept, except for exterior implies what?
Outside.
Outside. So what are my alternate exteriors?
1 and
So 1 is alternate exterior with what other angle?
8.
8. So again, top and bottom. So 1 and 8,
2 and 7.
and 2 and 7. Getting lazy. Alright, and then we have consecutive interior, which is the same thing. Consecutive is the same thing as saying the same side. And it kind of depends on the publisher of the textbook, but it's saying the same thing. So if you guys see consecutive interior, or you see same side interior, it's meaning the same thing. So same side implies what?
It's on the same side of the
Of what?
transversal.
Yeah, they're on the same side of the transversal. And interior means what?
They're in between the parallel.
They're in between the parallels.
4 and 6.
3 and 5 and
4 and 6.
3 and 5, 4 and 6. Okay. And not only do we have same side interior, but we could also have same side exterior, which would be 1 and 7, and 2 and 8.